So I'll introduce myself. I'm the professor, one of the professors. We have two, so I'll be teaching the first half of the course. My name's Robert Heinemann. I'm adjunct faculty. It means I'm part-time. This is the only class I teach here at University of Maryland. I have a full-time job at MITRE Corporation. My background is I'm computer science undergrad, and then I did an information systems master's degree, GMU. And then I went back, did a certificate program in computer engineering, and then I spent probably the last 20 years doing sort of hardware-based security assessments. So a lot of for those that have a formal computer engineering background, there's really not going to be too much theory. It's going to be very applied and practical. So you may have some of the skills. You may not. We're not going into the theory too deeply. So that's sort of the first half of the course. And then the second half is sort of the software that runs on hardware. So the first half is how to assess systems, understand where the data lies, how to instrument them, how to extract data, how to create test points. And then once you get that point, it's like, okay, now you've extracted something from it. How do you actually analyze the software from a security standpoint? And so what we're looking to accomplish is define what an embedded system is, basic structure of embedded system. How do we analyze printed circuit boards? So we'll look at those and understand what all the different components are, how they're connected together, how the diagnostics, how engineers use the diagnostics, how we can connect to those. We'll talk about test equipment and how to use them. We will talk about some basic soldering techniques. There is not a soldering lab here for those who haven't done that before. It'll give you a good foundation to actually be successful at some simple soldering. There's some simple things to keep in mind to sort of make that work. Learn how to instrument circuit boards so we can monitor buses, decode data, access diagnostic functionality. And then at that point, we'll get into the software. So we'll be focusing on the ARM architecture, which is what the BeagleBone Blacks are in here. And then basically evaluate assembly code in that architecture for security vulnerabilities. What are typical exploits, different exploit techniques, and then how to apply defenses to those to remediate ARM exploits. It's a very ambitious course, so it can be fast-paced.